Right? So the velocity component, due to this, has some magnitude and direction as I noted over there, right? And the 1 over r monopole over here would generate the velocity like this. Therefore, its normal component is equal and opposite. Therefore, sum of this is 0. So I only say the boundary condition of the baffled piston is automatically satisfied by using this 1 over r e to the j k r Green's function that I just introduced. So simply means that if I obtain pressure due to this surface, then I can obtain the pressure that is the same as the physical situation over here. You guys like this demonstration, but you guys do not like the mass. This is a simple mass. Okay. Maybe maybe the way I'm teaching is too boring. So what I eventually obtained is j k rho 0 c over minus 2 pi, and I have integration with respect to S0 exponential jkr over r un d S0 plus. That's the equation I obtained, and this equation we normally call Rayleigh equation. This integral equation essentially says that we can obtain the pressure at any field for the given UN distribution on S0. That's very nice. Okay, then let's solve it. We can of course solve it, but let's see special case first when the pressure along z-axis. Along z-axis. I want to see the pressure on this axis. Okay, then that is minus jk rho 0 c. This comes from omega because k equal omega over c, and we have omega because of the from the Euler equation, right? The reason why I did this is the characteristic impedance. So make the mathematical result to be more realizable in physical terms. So I changed omega to k. And 2 pi comes from 1 over 4 pi multiplied by 2. 2 comes from that we have two surface, identical surface, but different normal direction, okay? Then the S0 look like, the S0, I have a circular plate, and this is Z, And I have to integrate over the surface, so I consider small rim because it's a symmetry. And I say this is a dr, and I call this is a theta. Okay, therefore the whole area of this is what? 2 pi, and I denote this length zeta. I don't know why I introduced the zeta, but that's what was written in the text. So 2 pi zeta, and this has to be zeta, I'm sorry. Did I make a mistake? And then that's the whole area of this. And the z is point over here. And this is what? Capital R. Right? So that is a square root. Because this is right angle, that is a z square plus zeta square plus a z square. So my integration look like zeta square plus z square exponential j k square root, and I have un, and this one, so I have un, and this one is 2 pi zeta d zeta, and I am integrating this from 0 to a. Okay? You follow me? Okay, let me repeat. So you got this. This is Rayleigh integral equation. Rayleigh integral equation, okay? Rayleigh integral equation. And our job is converting this to, in terms of the coordinate that appropriately express our integration. The surface, we assume that the piston has a circular piston shape, not rectangular. Okay. I'm sorry. The piston has a circular shape, okay? And this is oscillating like this, therefore it would not depend on the theta direction, right? So surface integral would be integrating this strip and let this strip come starting from here to there. All right? So expressing this using the coordinate zeta we just introduced would be 2 pi zeta. That is the circumferential length, and multiply the zeta give us the area of this strip. And then I let this zeta from 0 to a. And then r, that is the distance from any point on the strip to the point that I want to predict a sound, that is z. That has to be, because this is the right angle,